The Mars Sample Return Campaign is an effort to safely return samples of Martian rocks and soil to Earth, where they can be studied in incredible detail using all of terrestrial laboratories' capabilities. The mission would collect and send samples of Martian rocks, soils, and atmosphere to Earth for detailed chemical and physical analysis using robotic systems and a Mars Ascent rocket. It is part of NASA's long-term undertaking of robotic exploration of the Red Planet. NASA's various centers are collaborating with the European Space Agency to build the advanced technologies and hardware required for the campaign. The first leg of this international interplanetary relay team is the Mars Perseverance rover. Its mission on Mars is to collect and store samples. A sample retrieval lander would land near or in Jezero crater, bringing with it a small rocket into which Perseverance's samples would be loaded. NASA chose the Jezero crater as the landing site for the Perseverance rover because scientists believe the area was once flooded and was home to an ancient river delta. The landing site selection process included a collaboration of mission team members and scientists from all over the world who carefully examined more than 60 candidate locations on Mars. After a 5-year investigation of potential sites, each with its own distinctive features and characteristics, Jezero emerged as the clear winner. NASA's sample retrieval lander would land on Mars and remain there to collect a wide assortment of scientifically curated Martian rock samples already collected and categorized by NASA's Perseverance rover. The lander would be the first to carry a rocket, NASA's Mars Ascent vehicle, and 2 helicopters to help achieve the goal of safely returning samples to Earth for study. The Mars Ascent vehicle would launch from Mars, carrying samples into the Mars orbit to meet the European Space Agency's Earth Return Orbiter. The samples would then be delivered to our planet by the orbiter. The 2 NASA sample recover helicopters, customized versions of the Ingenuity Mars helicopter brought to Mars by Perseverance, would function as backups for Perseverance tasks of delivering sample tubes to the lander. Furthermore, the lander would be equipped with ESA's sample transfer arm, which would be used to load the sample tubes for return to Earth. The Sample Transfer Arm, or STA, will be critical to the success of the Mars Sample Return mission. The goal is to return Martian samples to the best labs on our planet by 2033. The robotic arm will land on Mars to retrieve the sample tubes being collected from the surface by NASA's Perseverance rover. The Sample Transfer Arm, which is capable of seeing, feeling, and making autonomous decisions, will identify, pick up, and transfer the tubes into the Mars Launch System, the first rocket launched from another planet. The sample retrieval lander would play a crucial role in delivering critical spacecraft and hardware to Mars, including the rocket that would launch samples from Mars, and as mentioned earlier, 2 helicopters and a robotic arm to move the samples into the rocket. When the samples arrive on Earth, scientists from all over the world would examine them with sophisticated instruments that are too large and complex to send to Mars. The samples would be preserved for future generations to study using increasingly sophisticated technologies. Scientists believe the samples will reveal whether or not life ever existed on Mars. You may be wondering how the lander will aid in the launch of the Mars Ascent vehicle. The Mars Ascent vehicle would be launched by the lander by tossing it up to 14.8 feet above the lander, or 21.3 feet above the Martian surface. Once in the air, the rocket would ignite and take off, releasing the sample tube container into a stable orbit around Mars in preparation for a rendezvous with ESA's Earth Return Orbiter. To facilitate the transfer of Mars samples, the lander must be close to the Perseverance rover. It must land within 66 yards of its intended landing site, which is significantly closer than previous Mars rovers and landers. The lander would use an improved version of NASA's successful terrain relative navigation system, which helped Perseverance land safely. Among other advancements, the new enhanced lander vision system would include a second camera, an altimeter, and improved propulsion capabilities of precision landing. NASA and ESA are working together on a follow-up campaign that will include a NASA-led sample retrieval lander that will launch the retrieval samples aboard the Mars Ascent vehicle. When the sample container reaches Mars orbit, an ESA-led Earth return orbiter will rendezvous with it and safely return the precious cargo to Earth. In order to prepare the sample tubes for launch into orbit around Mars, the lander would communicate with the Perseverance rover, the sample recovery helicopters as needed, and the Mars Ascent vehicle. The task necessitates numerous highly accurate robotic arm movements, which will be carried out by ESA's sample transfer arm. The Perseverance rover would then deliver its samples directly to the sample retrieval lander, as currently planned. The lander would also transport and deliver the two NASA helicopters to Mars as an alternative method of delivering samples stashed on the surface by Perseverance. Once the samples arrive on Earth, scientists intend to conduct detailed chemical and physical analysis in laboratories around the world in order to look for signs of past life on Mars and to conduct a variety of other studies that go beyond the capabilities of the instruments delivered to Mars.